We give an introduction to plane curves and parametric equations. One, we give the definition for the plane curve and what it also means for a curve to be smooth. And then we look at what the parameter is and what that means. And then how we're able to graph a parametric equation by somehow eliminating the parameter and resulting with what I call, eventually we'll talk about this, a rectangular equation, and that is an equation in terms of x and y. So a parameter t is said to be a quantity of time. And how does time relate to a function y equal to f of x, where x and y are somehow related to the time? Well, obviously, if there's a particle in space that's moving, we can calculate the velocity of that particle in terms of x and y relative to the time. We can measure the angle of elevation of that particle when it's initially being thrusted off into space. We can talk about that angle also as a parameter, theta. And so the two common parameters would be time and the angle, theta, relative to values of x and y. And then if it's typically in the third dimension, relative to z also. The definition of a plane curve: f and g hopefully are continuous functions of t on some open interval I. Then the equations x equal to f of t and y equal to g of t are called parametric equations, and t is said to be the parameter, whether it's t or theta. Either one is representative of parametric flow. Together here, the equations with the graph, we call that the curve. Definition of a smooth curve: a curve is said to be smooth if its derivatives, all of its derivatives, first derivatives, are continuous. Eventually in calculus 3 we'll talk about a smooth curve where the partial derivatives are continuous within that particular interval. Our objective then is to sketch the graph of a curve to show the orientation or the direction of the graph. Also, we want to be able to eliminate the parameter resulting in an equation of x and y. But that doesn't help us to graph. You can graph in terms of x and y, but in terms of trying to get an idea of how the particle, what direction the particle is moving along that path, is questionable unless you consider the parameter t or theta. Let's see. Take this first problem. Sketch the curve represented by the parametric equations. Indicate the orientation, that is the direction of the graph, and then write the corresponding rectangular equation by eliminating the parameter. But it's no problem. So here, notice that if you square x, that gives us t. And then for the second equation, y is equal to t, that is now x squared minus 5. Well, we know that this is a parabola, but what direction and what values do x and y take on relative to t? Our parameter, then we can deduce values for x and y. So obviously time has to be positive, so at the initial time, x is 0, and then y is negative 5. Then what about when t is equal to 1, x is 1, and then y is equal to negative 4? Well, that's all we need in order to get the direction. So here, when x is 0, y is negative 5, we're looking at the right side of this parabola. So we start here at x equals 0, y is negative 5. Then we go to 1, negative 4. So as you can tell, we're moving in that direction, and that's the orientation. Well, that's it. Let's look at this one. Well, tangent square and secant square relate in this accord that 1 plus tan square theta is equal to secant square theta. So we get 1 plus tan square is x, that's equal to y. So we can write this as y is equal to x plus 1. Just a straight line. But now, what about the direction? So theta now is our parameter. We have x, we have y. So if theta is 0, then tangent of 0 is 0. And secant of 0, that's 1 over cosine. Well, cosine of 0 is 1. So we get 1 squared. So let's take another number for theta, some other angle, excuse me. Let's say that if theta is, let's say power 4. So if theta is power 4, then the tangent of power 4 is 1. You square that, you just get 1. And here, power 4 for cosine is 1 over the square root of 2. For secant, that's the square root of 2. Secant squared, we just get 2. I think that's enough to show the graph. So x is 0, y is 1. We're there. And then x is 1, y is 2. X is 1, y is 2. So we're, excuse me, why did I pick down there? I didn't mean to do that. I'm thinking about the previous problem, probably. Okay, going crazy. X is 1, x is 0, y is 1. So we're here. And then x is 1, y is 2. X is 0, y is 1 for the first point. X is 1, y is 2. Let me get it right. Get it right, Ernest. So it's something like that. We're going to just draw a straight line through that. I need help with my straight lines. It starts here because here theta 0, x positive. The direction. What about this one? So x is equal to 8 cosine theta, y is equal to 8 sine theta. Cosine and sine relate to this identity. So we replace the cosine. Now cosine is x divided by 8, right? And here, sine theta is y divided by 8. So we get x over 8 to be squared plus y over 8 to be squared is equal to 1. So this is x squared over 64 plus y squared over 64 is equal to 1. And I was hesitant because I wanted to just go ahead and just write it as x squared plus y squared is equal to 8 squared. So this is a circle, right? Circle with radius 8. But let's determine the direction, theta, x, and y. So theta is 0. theta is 0, cosine of 0 is 1, so x is equal to 8, and y would equal to 0. Let's try power over 2. So cosine of power over 2 is 0. Sine of power over 2 is 1 times 8 equal to y, so y is equal to 8. I wonder if this thing has a circle on there that we can use. There's a circle. Let's try that. Now, okay, this is 8 on the x-axis, and this is 8 on the y-axis. We start off with 8, 0. We're there, and then we go to 0, 8. We're up here. So the point is we're moving in that direction. What about this one? Again, we know how cosine and sine relate. So this is x over 3 to be squared, which is the cosine squared. It's going to be plus y over 7 to be squared, because that's going to represent the sine squared. It's equal to 1. So here we get x over 3 squared plus y over 7 squared is equal to 1. Well, since 3 and 7 are different, if they were the same, we have a circle. But since they're different, we have an ellipse. So, again, we need some direction values. So if theta is 0, cosine of 0 is 1, so x is equal to 3, and we get y to be 0. If theta is power over 2, cosine is 0, sine is 1, so we get y to equal to 7. All right, so the x values, we want to go out there to plus or minus 3 because of that term downstairs. That's the a. Maybe I should just write it like that. And the b is plus or minus 7. So 1, 2, 3 for a, 1, 2, 3 for negative a, 1, 2, 3, 4, 5, 6, 7, 2, 3, 4, 5, 6, 7. All right, so we draw the ellipse. Okay. It's an ellipse, or it's my face. But anyway, so x equals 3, y equal to 0 is there, and then x equal to 0, y equal to 7. So as you can tell, we're moving in this direction. So that's the orientation. Okay. Well, I think that'll do it for today. Thank you.